Hello, this is Ravis Key. I'm going to teach you a little bit about calculating average atomic mass. So imagine you found a big chunk of carbon out in nature. You would find that 99% of it would be carbon-12, and then you'd have isotopes, carbon-13 at 0.90%, and carbon-14, which we use for dating older fossils and items, that's only found at 0.10%. So how do you actually find the average atomic mass with all these percentages? Well, the first thing you're going to do is move the decimal 2 places. So when you do that, you're going to multiply 12 times 0.99 to get 11.88. We're going to do that same process 2 more times. Remember, you got to put in zeros here and multiply 13 times 0.0090 to get 0.117. And then we're going to do the same thing down here, adding 2 more zeros and moving that decimal so that we see that it's going to give us a 0.0141. We're going to add up all of these numbers and we get 12.0 excuse me, 12.011. It's going to be an AMU, which stands for atomic mass unit, or grams, which you could abbreviate with just G. All right, that worked out pretty well. What if we had a metal that is unknown, but we have its isotopes? I actually really like this problem, but be careful. There is no element X, so please don't spend several minutes looking on the periodic table for element X. So I'm going to go ahead, but before I leave carbon, if you grab a periodic table, you will see that carbon has the mass, if I can get it in the camera, 12.011. So that's where that number comes from the isotopes. So let's try another problem, but this time not only do we have to find the average atomic mass, we have to identify the element. So here we go again, moving the decimal, multiplying it out. You're going to have 3.132, moving the decimal, that's a big one there. And that's going to give you 51.3632. People are always asking me, when do I round? I would be careful rounding here because you really need digits to help you sort out which element it is. So I'd go ahead and keep several digits if I were you. So when you multiply these, you're going to get a smaller number, 1.254. And of course on the last one, don't forget your zeros. And that's going to give you a very small number, 0.1624. And when you add these up, you get 55.9116. Again, AMU or grams. So now, I'm not done yet. I'm going to grab my handy dandy periodic table and I'm going to start looking. Well, I see 54.9, 55.845, and 58. So clearly, the closest one that's a tenth away, or actually about a half a tenth away, is iron, and that would be our answer. So you can either write out iron or just the symbol Fe. All right, well, let's make it real. Your grade in this class is also calculated using the same method as the average atomic mass. So using your syllabus, you have these percentages this COVID-19 season. So again, we're going to move the decimal 2 places. And on your progress report in several weeks, you're going to see an average for your seated test grade. So we're going to multiply the 0.35 times your average. And that's going to give us a handy dandy number there of 28. We're going to do it again. Times 90 and get 18. Do it again. Times 80 and get 16. And of course, when you move 25, it makes it easy. With 100, it's just 25. Okay, and again, you add up all these numbers to see that you get an even 87. I'm even going to put a 0 there to show you there's no position there, you have truly made an 87.0 in the class, and that's exactly what should be in your power score. So hopefully you'll be able to check that when you have your progress report in a few weeks. I hope this helps, helping teach you about average atomic mass.